Okay, today in algebra we're talking about quadratics by factoring. We've been taking kind of a break because of tax, so some of this might be review for you. For some of you it might seem like it's totally new. So you just kind of need to bear with me, make sure that you're getting all the information you can to do a good job. Let's start with part A, which is called the zero product property. Look at example number 1. This is already factored for you into x minus 3 times x plus 7 equals 0. Now, your first instinct when you see that should be, oh, I need to either do box or FOIL because I'm multiplying two binomials. But that's not what I'm asking you to do here. I'm asking you to solve using the factored form, using the zero product property. When I'm doing this, what I'm finding is the roots. So we talked a lot about that during tax time. Where does it cross the x-axis? When I have a factored form, I can set each factor equal to 0, that's the zero product property, and solve, and that will give me the two places where it crosses the x-axis. So I'm going to say x minus 3 is equal to 0, and x plus 7 is equal to 0, and now I have two little problems to solve. On this one, to get x by itself, I'm going to add 3 to both sides. When I do that, I've got x equals 3, and I'm done. That's one of my roots. And the other one, I'm going to solve for x by subtracting 7 from both sides. And when I have x equals negative 7, that's my other root, and I'm done. That's my answer. Let's practice a few more like this. Example number 2. If I have x times x minus 5 equals 0. Again, it's already factored for me. Now I just need to set the factors equal to 0. Zero product property tells me if I set them equal to 0, then I have my answer. So I have x is my first one, x equals 0. Nothing to solve there, that one's done. And x minus 5 equals 0. To get x by itself, I'm going to add 5 to both sides. Done. X equals 5. So my two roots are 0 and 5. Now remember when we talked about roots, there might be 2, there might be 1, there might be 0. That's what a quadratic does. Remember, that's those parabolas. They could touch, they could cross, they could never cross at all. So those are kind of our options. Let's look at another example using zero product property. X plus 4 times x minus 3 equals 0. I have my two factors. I want to set them equal to 0. X plus 4 equals 0. X minus 3 equals 0. I'm going to subtract 4 from both sides on the first one. X equals negative 4. That's my first factor. On the second one, add 3 to both sides. And x equals 3 is my second one. Those are my two roots. Those are my two answers. Now, what do I have to do if it's not factored? So to solve by factoring. You'll remember that we have to use my father drives a red Mustang to factor. So we're going to do that. And then it's exactly like part A. So example number 4. If I'm given x squared plus 7x plus 10 equals 0, and I say my father drives a red Mustang, what multiplies to get a times c? So a is 1, c is 10, so that'd be 10. That'd be 1 and 10 and 2 and 5, right guys? What finds my factors f to get to b? That'd be 2 plus 5 is 7, so these are out. Divide by a, which is 1. Reduce, I can't reduce those, and make my multiples by writing x and reading up. So my factors are x plus 2 and x plus 5 equals 0. Now it's what I just did in the previous problem. Set each of those equal to 0 and solve. On the first one, I'm going to subtract 2 from both sides, and x equals negative 2. On the second, I'm going to subtract 5 from both sides, and x equals negative 5. And I'm done. Let's look at another one. Example number 5. I'm going to do x squared minus 2x, actually let's do plus 2x, and minus 8 equals 0. Notice every time my problems are being set equal to 0. I can only use the zero product property, which is what we learned in part A. If it is equal to 0, that's how I'm getting these two pieces out. If it's not, we'll have to do some more solving. So let's go ahead and look at that here in a second. Start by factoring this. A times c, 1 times negative 8 is negative 8. The factors are 1 and 8, 2 and 4. I want them to add to be positive 2, but multiply to be negative 8. So I know one of these has to be negative. 1 and 8 doesn't make 2, but 2 and 4 will make 2 if I do 4, subtract 2, right? 4 minus 2 is 2, negative 2 times 4 is negative 8. Divide by that a, which is 1 in both cases. Put your x's in, read up. So I have x minus 2 and x plus 4 equals 0. Take those two factors and set them equal to 0. Add 2 on this one, and x equals 2. That's one of my roots. Subtract 4 on this one, and x equals negative 4 on that one, and we are good to go. Let's try one more problem. if I want to do example 6, x squared plus 2x plus 1 equals 0. If I want to factor that, a times c is 1. What multiplies to 1? 1 times 1. Guess what? 1 plus 1 is 2, so that's great. That worked out well. Divide both by a, which is 1. Write your x's on bottom and read up. So I have x plus 1 times x plus 1 equals 0. Okay, now what happens here? X plus 1 and x plus 1 is exactly the same. So if I say x plus 1 equals 0 and x plus 1 equals 0, subtract 1 from both sides. X equals negative 1. Subtract 1 from both sides. X equals negative 1 again. So that's not really two roots because it's in the exact same place. It's the same root and there's only one solution here. And that has something called multiplicity, which is something you'll talk about much later in your math life. But just understand that if they're exactly the same, you only need to box one in. That's one solution. Your assignment for this is page 633. It's numbers 1 to 9 and 26 to 28. Good luck, and let me know if you have questions.